Step outside on Venus without a suit, and you wouldn't just die. You'd be crushed flat, cooked, and dissolved in acid, roughly all at once, in under 2 seconds. And that's actually one of the gentler deaths on this list. 8 planets. 0 mercy. Let's find out exactly how long you'd last on each one, and which one might, somehow, be survivable. Every planet in our solar system has its own specific, catalogued way of killing an unprotected human, and scientists have actually calculated most of these deaths in exact seconds and minutes using real atmospheric data from probes, landers, and orbiters. This isn't science fiction. This is what NASA's own instruments have measured, planet by planet, death by death, starting closest to the Sun, in the one place death arrives fastest of all. Mercury doesn't kill you once. It kills you twice, depending on which side of the planet you're standing on, and the 2 deaths are almost total opposites. On the sunlit side, surface temperatures reach 430 degrees Celsius, hot enough to melt lead, hot enough that your body would begin failing within seconds of direct exposure, skin blistering and vital proteins breaking down almost instantly. But walk into shadow, and the temperature crashes to negative 180 degrees Celsius in the time it takes to cross a football field, because Mercury has essentially no atmosphere to hold heat, meaning you could, in theory, freeze and cook within meters of each other on the same airless rock. The reason for this brutal split is simple. Mercury's atmosphere is so thin, 1 trillion times less dense than Earth's, that it can't distribute heat at all. Whatever the sun touches, bakes. Whatever it doesn't, freezes almost instantly, because there's no air to insulate or hold warmth after dark. Add to that 0 oxygen and 0 air pressure, and the truth is you wouldn't survive long enough to worry about temperature anyway. The moment you were exposed to Mercury's vacuum-thin atmosphere, the lack of pressure would begin pulling gases out of your blood within about 15 seconds, a process similar to what divers call the bends, except catastrophically faster. Survival time on Mercury, unprotected, roughly 15 to 20 seconds, and that's being generous. If Mercury kills fast, Venus kills faster, and in more ways at once. Venus is often called Earth's twin because it's nearly identical in size, but the comparison ends the moment you look at what's actually happening on its surface. The atmospheric pressure on Venus is 92 times that of Earth, equivalent to the crushing pressure found nearly a kilometer deep in Earth's oceans. That pressure alone would collapse your chest cavity and crush your lungs within seconds of exposure. But that's only the beginning. Venus's atmosphere is 96.5% carbon dioxide, wrapped in thick clouds made almost entirely of sulfuric acid. Not a trace, not a mist, but genuine concentrated sulfuric acid droplets, constantly raining down, though the heat is so extreme the acid rain evaporates before it ever reaches the ground. Surface temperature averages 465 degrees Celsius, hot enough to melt lead, zinc, and even some low melting point metals. And this heat doesn't fluctuate much between day and night because Venus's thick atmosphere traps it uniformly across the entire planet. The strongest greenhouse effect of any planet in the solar system, by a massive margin. Here's the retention hook. Soviet landers actually tried to survive this. Between 1970 and 1982, the USSR successfully landed 13 Venera probes on the Venusian surface. Most were crushed, melted, or lost contact within 23 to 127 minutes of touching down, not because of a design flaw, but because nothing built by humans has ever been proven to survive Venus's surface conditions for longer than about 2 hours. A human, unprotected, wouldn't need 2 hours. Combined pressure, heat, and acid exposure would end things in an estimated 1 to 2 seconds, arguably the single fastest planetary death of the 8. Quick recap before we leave the inner solar system. Mercury kills you in 15 seconds through pressure loss and thermal extremes. Venus kills you in under 2 seconds through crushing pressure, heat, and acid. Now we land on the one planet where you'd actually survive, Earth, and it's worth pausing here, because Earth's habitability isn't an accident. It's an absurdly narrow coincidence of conditions that almost none of the other 7 planets share even slightly. Earth sits in what astronomers call the Goldilocks zone, close enough to the Sun for liquid water, far enough to avoid a runaway greenhouse effect like Venus's. Our atmosphere is 78% nitrogen and 21% oxygen, held in place by gravity strong enough to retain gas but not so strong it crushes you, and further protected by a magnetic field generated by our planet's molten iron core, which deflects most of the sun's radiation and solar wind that would otherwise strip our atmosphere away entirely, a fate that likely happened to Mars billions of years ago. Take away that magnetic field, and Earth would slowly become an airless, radiation-blasted rock within a few 100 million years. But that wasn't even the most fragile part of the equation. Earth's average surface temperature sits right around 15 degrees Celsius, warm enough for liquid water to exist stably across most of the planet, a condition that appears to require an almost impossibly specific orbital distance, atmospheric composition, and axial tilt working in tandem, move Earth even 5% closer to the Sun, and models suggest a runaway greenhouse effect similar to Venus's could begin. Before we head further out, it's worth stopping at the Moon, technically not a planet, but the only other body in the solar system humans have actually walked on, and a useful preview of what no atmosphere really means for the human body. The Moon has no breathable atmosphere at all, essentially a hard vacuum, meaning the moment you're exposed unprotected, the pressure differential between your body and the surrounding air would begin forcing gases out of your bodily fluids within about 15 seconds, the same Benz-like effect as Mercury. Unconsciousness from oxygen deprivation would follow in roughly the same window, somewhere between 15 seconds after exposure. Actual death would take slightly longer, up to about 1 to 2 minutes, according to NASA's own physiological data on rapid decompression. Because the body doesn't instantly stop functioning the moment breathing stops, the brain can survive a short window without oxygen before permanent damage sets in. Fun, dark fact: your saliva and the moisture on your eyes would begin to boil, not because of heat, but because of the vacuum itself lowering the boiling point of liquid dramatically, a phenomenon called ebullism. Recap and bridge: Mercury, Venus, and the Moon have taught us the two fastest killers in space are extreme pressure and total vacuum. Mars, our next stop, kills you with a mix of both, plus one additional threat almost nobody expects. Mars gets marketed as humanity's next home, and in fairness, it's the least hostile of the non-Earth planets, which is a low bar that still ends in death within minutes. Mars's atmosphere is less than 1% the density of Earth's, composed of 95% carbon dioxide, and its atmospheric pressure is so low that unprotected exposure would cause the same ebullism effect as the Moon. Bodily fluids beginning to boil at body temperature because there's not enough pressure to keep them liquid. Unconsciousness would set in within about 15 seconds due to lack of oxygen, and death would follow within roughly 1 to 2 minutes, almost identical to lunar exposure. But Mars adds its own signature threat: dust storms. In 2018, a single Martian dust storm grew so large it enveloped the entire planet for weeks, blotting out the sun so completely it ended NASA's Opportunity rover mission after 15 years of continuous operation. The rover's solar panels simply couldn't gather enough light to recharge, and it went silent on June 10, 2018, never to respond again. Add to this a surface temperature that swings from a relatively mild 20 degrees Celsius at the equator during the day, down to negative 125 degrees Celsius at the poles at night, and near-constant exposure to radiation because Mars lost its protective magnetic field an estimated 4 billion years ago, meaning any human colony would need meters of shielding, likely underground or beneath thick regolith, just to survive long-term radiation exposure that would otherwise sharply raise lifetime cancer risk. Survival time unprotected on the surface, roughly 1 to 2 minutes, the same as the Moon, but with worse long-term prospects if you somehow had a suit and were trying to actually live there. Let's move fast through the region most people forget exists between Mars and Jupiter. The asteroid belt isn't a planet, but it's worth 90 seconds of your attention, because it's often misrepresented in movies as a dense minefield of rocks slamming into each other constantly. In reality, the average distance between objects in the belt is roughly 1 million kilometers, meaning most spacecraft, including the New Horizons and Voyager probes, pass straight through without a single close call. There is no breathable atmosphere anywhere in the belt, no pressure at all, meaning exposure there would be identical to open space vacuum exposure. Unconsciousness in about 15 seconds, death within roughly 1 to 2 minutes, same as the Moon and Mars. The belt's most famous resident, the dwarf planet Ceres, has been confirmed by NASA's Dawn mission to contain actual water ice and even organic compounds, making it, strangely, one of the more scientifically interesting almost nothing places in the entire solar system. Now we reach the gas giants, and this is where survival numbers stop being measured in minutes, and start being measured in seconds again, because Jupiter doesn't have a surface at all. There's nothing to land on. You'd simply keep falling, through layer after layer of increasingly dense atmosphere, primarily hydrogen and helium, until the pressure and temperature became so extreme that gas itself would begin behaving like a liquid metal, a state scientists call metallic hydrogen, believed to exist deep in Jupiter's interior under pressures millions of times greater than Earth's atmosphere. Long before you'd ever reach that layer, you'd already be dead. At just 550 kilometers below Jupiter's visible cloud tops, atmospheric pressure reaches roughly 10 times Earth's. Survivable briefly with the right suit, but unprotected, your body would already be showing severe compression trauma. Continue falling, and within a few more 100 kilometers, pressure would exceed anything the human body could withstand, crushing internal organs entirely. On top of the pressure, Jupiter's winds reach speeds up to 620 kilometers per hour in its storm bands, and the planet's magnetic field is the strongest of any planet in the solar system, roughly 20,000 times stronger than Earth's, generating radiation belts so intense that NASA's own Juno spacecraft had to be built with a special titanium vault just to protect its electronics long enough to complete its mission. Estimated unprotected survival time falling into Jupiter. Seconds, not minutes. Somewhere in the range of 1 to 2 seconds before crushing pressure and lethal radiation exposure combine into a death that's almost impossible to separate into a single specific cause. Quick recap, from Mercury's 15-second thermal death, to Venus's 1 to 2 second crush and cook, to Mars and the Moon's minute-long vacuum deaths, all the way to Jupiter's near-instant crushing collapse, the pattern is becoming clear. The bigger and denser the planet, the faster and more absolute the death. Saturn, our next stop, follows the exact same brutal math, just wrapped in a far more beautiful package. Saturn shares Jupiter's core problem: no solid surface, just increasingly dense layers of hydrogen and helium gas that eventually transition into a liquid, metallic state deep in the planet's interior. Wind speeds on Saturn are even more extreme than Jupiter's, reaching an estimated 1,800 kilometers per hour at the equator, the fastest sustained winds recorded on any planet in the solar system, more than 4 times the speed of the strongest hurricanes ever measured on Earth. At those speeds, a human body without extreme protection would be torn apart by wind shear alone, long before pressure or temperature became the deciding factor. Saturn's iconic rings, made mostly of ice particles ranging from tiny grains to chunks the size of houses, would add an additional hazard. Any spacecraft or body passing through the ring plane risks high-speed collisions with debris traveling at orbital velocities of several kilometers per second, fast enough that even a pebble-sized ice chunk could shatter a spacecraft. Estimated survival time falling into Saturn's atmosphere, unprotected, roughly 1 to 2 seconds, nearly identical to Jupiter, the wind shear alone likely ending things before pressure or temperature even become relevant. Uranus is the solar system's strangest planet for one specific reason that has nothing to do with temperature or pressure. It rotates almost completely on its side, tilted 98 degrees relative to its orbit, likely the result of an ancient, catastrophic collision with an Earth-sized object billions of years ago. This means Uranus experiences the most extreme seasons of any planet. Each pole gets roughly 21 years of continuous sunlight, followed by 21 years of continuous darkness, an unbroken cycle that would make any concept of day and night as humans understand it completely meaningless. Beneath its hazy blue-green atmosphere of hydrogen, helium, and methane, the methane is what gives Uranus its distinctive color, absorbing red light and reflecting blue, lies something genuinely bizarre. Scientists believe Uranus and its neighbor Neptune both contain thick layers of superheated, highly compressed water, ammonia, and methane ices, under such extreme pressure and temperature that they may behave as a strange electrically conductive fluid sometimes nicknamed an ocean, believed to be the source of Uranus's oddly tilted, off-center magnetic field. Surface temperatures at the cloud tops average a brutal negative 224 degrees Celsius, the coldest atmospheric temperature recorded of any planet in the solar system, even colder than Neptune, despite Neptune being significantly farther from the Sun, a mystery scientists still haven't fully explained, since Uranus should theoretically retain more internal heat than it does. Estimated unprotected survival time: seconds, both from immediate extreme cold and from the crushing atmospheric pressure that increases the deeper you fall, with no solid surface anywhere to eventually land on. Recap and bridge before the 2 final, most extreme destinations. Uranus killed with confusing, extreme cold and a bizarre sideways tilted magnetic field. Neptune, the outermost official planet, takes the hostile atmosphere concept to the most violent extreme yet measured anywhere in the solar system. Neptune's winds have been directly measured by NASA's Voyager 2 spacecraft, the only spacecraft to ever fly past it, in August 1989, reaching speeds up to 2,100 kilometers per hour, the fastest winds ever recorded on any planet, human-made vehicle, or natural phenomenon anywhere we've measured in the solar system. At those speeds, a human body wouldn't experience wind in any survivable sense. It would experience something closer to being struck repeatedly by a wall of gas moving faster than most commercial jet aircraft. Beneath Neptune's deep blue methane-tinted clouds lies the same theorized superheated water ammonia methane ocean layer believed to exist inside Uranus, and beneath that, scientists believe, an even more extreme phenomenon, diamond rain. Multiple laboratory experiments simulating Neptune's interior pressure and temperature, published by physicists in 2017, successfully compressed carbon into actual diamond structures under conditions matching Neptune's deep atmosphere, leading scientists to believe it may genuinely, continuously rain solid diamonds deep inside the planet, a detail so strange it sounds invented, but is backed by real, repeatable laboratory physics. Estimated unprotected human survival time falling into Neptune: 1 to 2 seconds, wind shear alone likely proving instantly fatal before pressure or temperature ever become the determining factor. We're finishing at Pluto, reclassified from planet to dwarf planet in 2006, but still the destination that produces, by far, the strangest survival numbers in this entire list, because Pluto is simultaneously the most lethal and, in one bizarre technical sense, the most survivable body we've covered. Surface temperature on Pluto averages negative 229 degrees Celsius, cold enough that its thin atmosphere, composed mostly of nitrogen, with traces of methane and carbon monoxide, periodically freezes solid onto the surface as ice during Pluto's long, 248-year orbit, then partially sublimates back into a thin gaseous haze as it draws slightly closer to the Sun. Here's the true climax fact of the entire video. Pluto's atmospheric pressure is so astonishingly low, roughly 1/100,000th of Earth's, that unprotected exposure there would technically kill you slightly slower than instant vacuum-based deaths elsewhere on this list, because there's just enough trace atmosphere to marginally slow the ebulism process, but not nearly enough to prevent it entirely. NASA's New Horizons spacecraft, which conducted the only close flyby of Pluto in history on July 14, 2015, confirmed mountains of solid water ice up to 3,500 meters tall, and vast plains of nitrogen ice so smooth and crack-free that scientists believe it's evidence of an actively churning, semi-liquid nitrogen ocean beneath the crust, driven by residual internal heat billions of years after Pluto's formation, meaning Pluto, the coldest, most distant body on this entire list, may still be, quietly, geologically alive in a way scientists didn't expect to find that far from the Sun. Estimated unprotected survival time on Pluto: somewhere between 1 and 2 minutes, genuinely one of the longest survival windows on this entire list, purely because there's almost no atmosphere at all to crush, poison, or violently decompress you. The bitter irony of the whole video sits right here. The planet furthest from the Sun, the coldest, the one you'd expect to kill you fastest of all, might actually, technically, unprotected, let you live slightly longer than the beautiful blue-green ice giants sitting billions of kilometers closer to home. Out of 8 planets and 1 former planet, only one, Earth, lets you survive without a suit, and even that is an absurdly narrow, temporary coincidence of magnetic fields, orbital distance, and atmospheric chemistry that took over 4 billion years to stabilize. Every single other destination in our own solar system would kill an unprotected human in under 2 minutes, and in 6 out of 8 cases, in under 20 seconds. We are, statistically and physically, standing on the only safe rock for trillions of kilometers in every direction. If Pluto somehow outlasting Neptune surprised you, wait until you see our next video ranking the deadliest moons in the solar system, including one that might have an ocean warmer than Earth's. Drop a comment. Which planet's death surprised you the most? And subscribe if you want the full moon's follow-up the moment it drops.